So what do we want to know about the platelet plug formation here? So first, whenever there is an injury, happening, the first reaction which happens is, or you can just say, vasoconstriction. Okay, so whenever there is an endothelial injury, let's say endothelial injury, vasoconstriction happens. So what will this vasoconstriction lead to? So as soon as vasoconstriction happens, the next step is happening is the von Willebrand factor in our blood. Okay, this tends to expose to the collagen, the injured collagen. So now the von Willebrand factor binds to the exposed collagen. Okay, but this binding is not just simple binding. Okay, this combines with the platelets, but not just platelets. It combines with the alpha granules of the platelets. Alpha granules of platelets. So now the question arises, what is alpha granules of the platelets? Let's just see about the platelets. So as you can know, I can tell you, platelet has two types of granules in it. Okay, this has alpha granules, and this also has one known as delta granules. Okay, so now you will think, what is alpha granules and what is delta granules? It's very easy. Alpha granules are all with, like, all the factors of alpha granules starting with F. Okay, F. What are they? They are fibrinogen. I'll zoom in more. As you can see, there is fibrinogen. Next is fibrinonectin. Another one we know, von Willebrand factor, which obviously we know this is platelet factor A4. Okay, we will come this one, platelet factor A4, once again, but just now just remember that this is nothing but platelet factor A4, fibrinonectin. Okay, these are all alpha granules. So what are delta granules? The next question people ask you, what is delta granules? So delta granules are the chemical substances like calcium plus 2, ADP, serotonin, or the histamine. Okay, these are the delta granules of the platelets. We'll see about these two. Okay, now let's come back to the point where we were studying about the platelet factors, von Willebrand factor combining with the alpha granules of the platelets. So what happens next? See, so once the this combination happens, this whole combination is known as Weber-Palade bodies. What do we call this thing? Weber-Palade bodies. So this is also something you have to remember. Weber-Palade bodies is what? Von Willebrand factor plus alpha granules. The next step which happens here is adhesion. This is a very critical step. What adhesion happens here? So the platelets which binds with the alpha granules making Weber-Palade bodies, now via GP1B receptors. Okay, GP. So I'm gonna write Weber-Palade bodies bind with GP1B receptors. Okay, and this receptor, this process is known as adhesion. Now after adhesion, as soon as this adhesion happens, there is a release of ADP and calcium plus 2. Okay, so ADP, calcium plus 2, and thromboxane A2. Okay, so these three structures are released on adhesion. So we know till now adhesion is happening there. So after adhesion, the next step which comes is known as activation. Okay, what do we call this one as? Activation. Okay, so now the activation is happening. So as soon as activation happens, what activation is? This ADP which get released here. Okay, this ADP which get released, now this go and bind with this ADP, go and bind with P2Y12 receptors. P2. So the at ADP with P2Y12 receptor binding, okay, this, what does this does? This activates the GP2. Okay, you guys tell me what is activate? Yes, you're right, GP2B3A. Okay, this activates GP2B3A, and what happens next? This activation of GP2B3A release the next steps which happens here is known as aggregation. Okay, so we now know what aggregation is happening. ADP with activates GP2B3A causes the aggregation of the, okay, and this aggregation is known as fibrinogen, like binds with the receptors of GP2B3A, all right, and links with the platelets and forms the plug. All right, so we now got to know about the